Welcome to the second season of Tech and AI. Enjoy the episode, and please subscribe. Thank you.
Imagine this. The streetlights on your block dim when no one's around, saving the city thousands. Or, algorithms that predict bus arrivals based on a game letting out at the stadium, not just some fixed timetable.
And the flood pumps, they're spinning up before the heavy rain even hits, not after the disaster has already started.
Right. And that is the big promise of a smart city. But I feel like we hear that term all the time. If you strip away all the buzzwords, what's actually under the hood? What makes it all work?
That's the billion-dollar question, isn't it?
And that's our mission for this deep dive. We are going to get past the marketing hype and really explain the full technology stack, the use cases that actually matter. And this is the crucial part for me, how smaller towns and cities can do this without a London-sized budget.
Exactly. We're going to break down the architecture layer by layer and look at how this stuff improves everything from traffic to public health, but also give you, a real strategy guide.
Okay, so let's start at square one. A smart city. It's not just about installing a few benches with Wi-Fi and holding a press conference, right?
Oh, absolutely not. At its core, it's about using a combination of, sensors, connectivity, data platforms, and then AI and automation to actually improve how we live and move and govern.
So the goal is the outcome for people.
The goal is always the outcome. It's not about the shiny gadgets. It's about better, more efficient services.
Okay, let's unpack that technology then. You said there are layers. If we're building this from the ground up, where do we start?
We start at layer one, sensing. This is where the data comes from. And everyone immediately thinks of cameras and maybe air quality monitors, which are, foundational.
Sure.
But what's really fascinating now are the non-obvious inputs. We're talking about acoustic sensing. So devices that don't record video but listen for the specific high-frequency sound of a pump about to fail, or the sound of breaking glass.
Wow, okay, so it's proactive. You're collecting data points that predict a problem, not just react to it.
That's the whole idea.
Yeah.
And you also have your traffic loops, smart utility meters, parking sensors, and crucially, those water level gauges in storm drains. They're the city's specialized eyes and ears.
But you can have all the sensors in the world, and if that data can't get home, it's useless. So that's layer two, right? Connectivity.
Connectivity. And this is where strategy really comes in. It's not one size fits all. You need a mix. For things like live video, you obviously need the big pipes fiber, 5G, Wi-Fi 6.
Low latency, high bandwidth.
Exactly. But for, say, a parking sensor that just needs to report occupied or free once an hour, you don't need 5G for that. You use something like LoRaWAN.
And why is that distinction so important?
It's all about power. It's a huge strategic hurdle. If you run every sensor on 5G, you're replacing batteries every few weeks. A LoRaWAN sensor can run for years on a single coin battery. It's about matching the network to the need.
So once the data is sensed and sent, it needs a place to go. That brings us to layer three, the data platform, the backend.
Yep, the city's brain. And here we get into data lakes and data warehouses. A data lake is where all the raw, messy stuff lands, the video streams, the audio files,
Right.
Totally unstructured. The data warehouse is where the cleaned up, organized data goes, the stuff that's ready for analysis. And you need streaming pipelines to process it in real time. And critically, APIs so different departments can actually use the same data.
Okay, this is where it gets really interesting for me. Layer four, AI and automation. This is where the action happens. But how do you get the AI engine to look at data from the traffic department and the weather department to make one smart decision? That sounds incredibly complex.
It is. That's the single biggest implementation hurdle, absolutely. It's not just about writing an algorithm. It's about harmonizing these totally different data sets. But when it works, you get what we call closed loop actions.
Right.
The system sees a problem and fixes it automatically. The acoustic sensor hears a fault, and it automatically triggers a work order in the maintenance crew's system. No human needs to intervene.
That's seamless. Okay, and the final piece, layer five, is interfaces. How do people, city workers and the public, actually use all this?
For city operators, you need clean, simple dashboards. For citizens, you want open data portals for transparency. And you really need simple tools like city apps or even multilingual messaging bots, say on WhatsApp, so anyone can report a problem easily.
Okay, so we've mapped the tech stack. Now let's make it real. Let's look at how the system actually plays out. Mobility and traffic feels like the obvious place to start.
It's the one everyone feels. And we've moved so far beyond fixed timers on traffic lights. Now it's about adaptive signals that respond in real time to what the cameras and sensors are seeing. If a main road suddenly clears, the light timings shift to help the congested side street.
And I've heard about transit signal priority. That's where a bus can essentially ask for a green light, right?
That's right. It allows buses or emergency vehicles to just glide through intersections. The outcome there is so measurable. Fewer delays, less fuel wasted idling, and even fewer crashes. It just works.
Okay, what about energy and street lighting? You hear this is one of the quickest ROIs?
It is. A smart streetlight that dims when no one's there and brightens when a pedestrian approaches. That can cut energy use by 40, even 60%. The savings are immediate.
And it goes beyond just saving money, right? It's about resilience.
For sure. Cities are using solar and battery storage to create microgrids. They can keep critical sites like water pumps or community centers running during a major power outage. The KPI is simple: uptime during the storm.
Let's talk about those foundational services: water, flooding, waste.
Smart water meters are a game changer, not just for billing, but they can detect a tiny leak in your home or in a city main almost instantly. The amount of water lost in old cities is just staggering. This helps fix that.
And for flooding, those level sensors you mentioned earlier.
They're everything. They trigger the pumps before the water level becomes a crisis. You shift from reactive sandbagging to proactive flood control. It's a total paradigm shift.
And with waste management, I'm guessing it's about smarter routes.
Exactly. Dynamic routing. The truck only goes to the bins that are nearly full based on sensor data. Fewer trips, less fuel, cleaner streets. Simple.
Okay, I want to get to this concept of a city digital twin. It sounds like something out of science fiction, but it's used for urban planning. Let me be skeptical for a second. This sounds massively expensive. Is this a tool just for the megacities?
That's a great question. And no, you don't need a perfect digital replica of the whole city. For a smaller town, a digital twin might just be of the floodplain or the downtown core.
So you scale it to your needs.
You scale it. It's a live 3D model that lets you simulate things. What happens to traffic if we add a bus lane here? How will floodwaters move around this new building? You can test it all virtually before you spend a single dollar on concrete.
It's virtual prototyping for a whole city. And what about maintaining the stuff we already have?
That's predictive maintenance. Instead of just replacing a pump every 2 years, you use vibration and temperature data to flag the one specific pump that's actually about to fail. You fix what's broken, not what's on a schedule.
This all seems to converge in public safety.
It really does. The biggest benefit is a common operating picture. The dispatcher sees the traffic data, the weather alerts, the sensor data all on one screen. It gives them instant context.
But, and this is a big but, we're talking about a lot of cameras, a lot of data collection. How do we balance safety with privacy?
It's non-negotiable. The goal has to be maximizing safety while minimizing intrusion.
So what does that look like in practice?
It means prioritizing on-device AI. The computer vision analysis happens on the camera itself, and only anonymized metadata like crowd forming or vehicle stopped gets sent, not the raw video. And you need ironclad governance and audit trails to prevent mission creep.
Okay, let's touch on the domains that are more about quality of life and equity. Environment, digital government, inclusion.
For the environment, think about hyperlocal air quality. Not just one reading for the whole city, but a dense network of sensors that can pinpoint pollution hotspots street by street. You can then manage traffic or industrial activity in those specific areas.
That's incredibly targeted. And for digital government.
It's about making things easy. We want omni-channel services. You should be able to report a pothole on an app, a website, or with a simple text message. And open data portals build trust. They let researchers and the public see the data the city is using.
And finally, health and inclusion. How does tech specifically help people who need it most?
By targeting need. During a heat wave, the system can send alerts directly to residents who are registered as elderly or at risk. Wayfinding apps can be tailored for low vision users. The whole point is to use technology to bridge gaps, not make them wider.
This all paints a really optimistic picture. But we both know that these projects fail all the time. What are the big pitfalls?
Oh, there are many. The first is vendor lock-in. You buy a proprietary traffic system and you're stuck with that one vendor for decades. Every little upgrade costs a fortune. It kills innovation.
And I've heard the term pilot purgatory.
Yes. The demo looks amazing, the pilot works great, but it never gets integrated into actual city operations. The vendor leaves and the project just dies. It becomes an expensive novelty.
Then there's cybersecurity.
Yeah.
Every new sensor is a new door for hackers to walk through.
It's a huge risk. Cities have to adopt a zero-trust policy and be absolutely rigorous about patching. Operational tech, or OT, often gets neglected compared to standard IT security.
And we can't forget the equity gaps. If the fancy new app only works for people in the wealthiest neighborhood, you've just made things worse.
You've just automated inequality.
So let's pivot to strategy. A mini buyer's guide for a city with a tight budget. What's the #1 rule?
Don't try to be smart. It's too vague. Pick one measurable goal. Don't say, we're implementing a smart traffic system. Say, we will cut bus delays on Route 3 by 20% in 18 months. That focus is everything.
And from a technical standpoint,
Architect for interoperability from day one. Demand open standards and documented APIs. You have to be able to own and export your data. If a vendor says their system can't talk to others, walk away.
you also mentioned edge processing. Why is that so critical?
For things where latency matters, like flood pumps or traffic control, you need the computation to happen on-site. You can't send data to a cloud server 1,000 miles away and wait for a response. That half-second delay could be the difference.
And what about the budget itself?
You have to budget for the entire life cycle. Sensors fail, they need calibration, software needs licensing. If you only budget for the upfront installation, the project will be dead in 3 years from neglect.
And underpinning all of it, privacy.
Privacy by design. Draft and publish a privacy impact assessment before you even start. Be transparent about what data you're collecting and why. That's how you build public trust.
So for a really small town, what's the best entry point? Where's the low-hanging fruit?
Start with high ROI stuff, smart street lighting and water leak detection. They often pay for themselves in utility savings. And leverage tools that are already out there. Use messaging bots for citizen requests. They work on even the most basic phones.
And what about measuring success? What KPIs actually matter?
In mobility, it's not traffic volume. It's bus on-time percentage and crash rate reduction. For energy, it's simple. Kilowatt saved. For water, it's the leak rate. And for digital services, it's first contact resolution. Did you actually make it easier for someone to get something done?
Let's wrap up by looking ahead. What's next? What are the near-term trends that are going to make these systems even better?
Well, we touched on it, but on-device AI is a massive game changer for privacy. The processing happens right there on the sensor, and only anonymized alerts go to the cloud.
And V2X is a big one. Vehicle to everything.
Huge. This is cars talking to traffic lights, to infrastructure, to each other. It will smooth out traffic flow in ways we can barely imagine today.
We should also see a move toward open standards finally taking hold.
It has to happen. It's the only way to fight vendor lock-in and let cities truly pick the best tools for the job, regardless of who makes them.
And finally, something called green compute.
Right. Being smarter about the energy footprint of all this. Scheduling heavy data processing for times when renewable power is abundant. Using more efficient hardware.
So at the end of the day, the core message is what?
That smart cities are built on tech sensors, AI, all of it, but they have to be centered on human outcomes, on resilience, and on privacy. Start small, demand open standards, and only scale what really works for your people.
So the final thought for you to take away is this. If you could pick one single pain point in your community, traffic, flooding, power outages, and tackle it with one measurable goal and open standards, where would you start?
Build cities that take care of people, not the other way around.